This question says find the derivative using the limit definition. The limit definition rather than the shortcuts for finding derivatives. So this is the definition of a derivative. The derivative of f of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. And the function we want to find the derivative of is square root of x minus 5. So I want to start with that definition of the derivative, and I'm going to do the limit as delta x approaches 0 of f of x plus delta x. So f of x plus delta x means that I'm going to change this x to x plus delta x. So that would give me the square root of x plus delta x minus 5. And then I want to subtract f of x. So I'm going to subtract square root of x minus 5 over delta x. So this is the derivative, but if we were to use direct substitution right now, we would end up with 0 over 0, the indeterminate form. So we're going to simplify this limit by multiplying by the conjugate. So it would give me the limit as delta x approaches 0 of square root x plus delta x minus 5 minus square root x minus 5 over delta x. And I'm going to multiply by the conjugate of the numerator, which is square root x plus delta x minus 5 plus square root x minus 5. So the conjugate is just changing that sign from minus to plus. And we have to do the same thing on the numerator and denominator. So I'm also going to multiply by x plus delta x minus 5 plus square root x minus 5. So then I'm going to do some simplifying. And in the denominator, I'm going to leave the expression in factored form because I'm hoping that that delta x will eventually cancel out. So I want to leave it in that factored form. But in the numerator, I want to multiply out those two binomials. So when I multiply, I would multiply this square root by the square root first. And because they're exactly the same square root, it's going to simplify to be what's underneath the radical. Then when you multiply these outside terms together, you get a positive. And when you multiply these inside terms, you get the same term except for negative. And so those middle two terms end up canceling each other out. So then finally, I'm going to multiply these last two terms together, and we get a negative. But because they're both the same radical, square root of x minus 5 times square root of x minus 5 will become x minus 5. So notice I put the minus in front of the parentheses because that minus is applied to the whole expression. So then I'm going to distribute this negative to both those terms to get the limit as delta x approaches 0 of x plus delta x minus 5 minus x plus 5 over delta x times square root x plus delta x minus 5 plus square root x minus 5. And we have some terms canceling out. We have a positive x and a negative 5 and a positive 5. So we're left with a delta x in the numerator which will cancel with that delta x in the denominator. So we have those delta x's canceling out. We have the limit as delta x approaches 0 of 1 over square root x plus delta x minus 5 plus square root x minus 5. And now that those delta x's canceled out, we can use direct substitution. And we would have 1 over square root x plus 0 minus 5 plus square root x minus 5. And we have 1 over square root x minus 5 plus square root x minus 5. Those are like radicals, and we can combine them together. That's 1 over 2 square root x minus 5. So we have the derivative calculation to be 1 over 2 square root x minus 5. In this question, we want to find the derivative of the function f of x equals 3x minus 1 over square root x. So to calculate the derivative in this example, I'm noticing that I have a fraction, and both the numerator and the denominator have the variable x in it. So I'm going to use the quotient rule to find the derivative here. So with the quotient rule in mind, I'm going to find the derivative, and we're going to start with the bottom, which I'm going to rewrite as x to the 1/2 times the derivative of the top minus the top times the derivative of the bottom. Let me just make sure you guys can tell that that is a prime, the derivative, all over the denominator squared. And then I'm going to start applying the derivative. I have x to the 1/2, and the derivative of 3x minus 1 would be 3. Derivative of 3x is 3. The derivative of 1 is 0. And then I'll use the power rule to find the derivative of x to the 1/2. So that's 1/2, that's the power, times 1 less than the power. So 1/2 minus 1 would be negative 1/2. And that's all over the denominator squared. So x to the 1/2 power squared, that will be x. You're multiplying those exponents together to get 1, an exponent of 1. So I'll continue to simplify here. At this point, we've calculated the derivative. I'm just using algebra to simplify. And I've got 3x to the 1/2. I'm going to write minus 1/2 x to the negative 1/2 times 3x minus 1 all over x. And what I want to do is factor the numerator. I've got a common factor of x to a power on each term in the numerator. I'm also noticing this 1/2 here. So I would like to get rid of that fraction in the numerator. So I'm going to multiply by 2 over 2 so I can have the same fraction in both terms. So I'm going to factor out the greatest common factor of 1/2 x to the negative 1/2. So I'm choosing the lower power. And when I factor out of this first term here, the denominator comes out. I'm left with 6. 2 times 3 is 6. And then because this x to the 1/2 doesn't match exactly x to the negative 1/2, I'm still going to have a factor of x in that term. And I'm going to get the power on that x by doing this exponent minus this exponent. That's negative 1/2 minus, I'm sorry, I've got it backwards there. I said that backwards. So I'm going to do this exponent here minus this exponent here. That's 1/2 minus negative 1/2. And then on the other term, the 1/2 is going to factor out. The x to the negative 1/2 is going to factor out. So I'm going to be left with minus 3x minus 1 over that denominator of x. This is going to give me 1/2 x to the negative 1/2 times 6, and I'll simplify this exponent here. 1/2 minus negative 1/2 will be 1/2 plus 1/2, which is 1. So we have x to the first power. I'll distribute this negative, and that gives me minus 3x plus 1. I can combine like terms in the numerator. That's 3x plus 1 over x. And then I can move this 1/2, move this denominator of 2 down. And then because this has a negative exponent, I can also move that factor down. So I would have 3x plus 1 over 2 x to the 1/2 times x. And because these both have factors of x, they both have a base of x, I can combine those exponents together to become x to the 3/2. And one more thing I could do here is to change this to the square root of x cubed.